Right, so in the following 4 lectures, we're talking about counting techniques and the probabilities. So we know how to do counting, and for something like 1, 2, 3, 4, right? That's the first thing we learned when we grew up. But for the complicated problems, we needed to learn some ideas to the counting. So this is it's about the so-called principle of counting. Okay, so if a procedure can be performed in several steps, each step you have several ways to do. Okay, then the number of ways the procedure can be performed in the order I indicate is the product of those numbers. Okay. So using this principle of counting, okay, let's try to figure out the formula. For the first case is the number of arrangements of n objects in a row. Okay, so you have n objects, could be a student in a row, right? Okay, so the number, that will be n factorial. How to do that, right? Now, how do you get, suppose you have n objects, right? So to put them in a row, so you have n objects, okay, n objects here. Okay, so you do one by one. So first of all, step 1, you have one choice. You have n different ways to select, right? N options to select one object. Then you put in the first place. Then you have n minus 1 objects left. So you have n minus 1 choices, the second step. The third step, you have n minus 2 objects left. So it will be n minus 2 ways to select the third object. Then you put it in a row. After you complete the last step, okay, you have this many numbers in each step. So the answer will be the product of these numbers. Okay, the product, okay, of these numbers is going to be n times n minus 1 times n minus 2, and so on. This is denoted by n factorial. Okay. If this is if you only select k objects, you stop, right? So the number of objects of k objects, okay, selected from the group of n objects, okay, and put in a row. How to figure out the number of arrangements? Okay, so here's the second formula. So the number of ordered sets of k objects in a row. Okay, of course they're selected from a group of from a set of n objects. Okay. Okay, let's figure out this formula. Well, all you have to do is just stop somewhere. So still n object set. So the first one you have n choices, you have an n object set, right? And the second one is n minus 1. So what is the last one? So you have a k, right, objects. So the last one will be n, not n minus k, will be n minus k minus 1. Okay. Right, then total you have a k objects, you already get k objects. So so the answer will be the product of those numbers. N minus k, if you remove the plus, is n minus k plus 1, okay? Now, how do you express this? This can be expressed in the simple form, n factorial n minus k factorial, okay? I said order the sets. We still count the order, they're put in a row. Now, if you do not put them in a row, okay, no order, without order, okay, then you have to divide by k factorial, okay? Then you divide by k factorial. So the answer here is the number of, for example, groups or teams, okay, or sets or groups. When we say groups, then there's no order of k objects, okay, and selected from a group of n objects. Now, in this case, if you permutate those k objects, you still get the same order, you get same group. That's why you have to divide by k factorial, okay? So that will be n minus 1, n minus k plus 1 divided by k factorial. So you combine them, you get this formula, okay? So this is a formula we use that to, for example, select 3 students from a class of 24 students to form a committee, okay? The committee, there's no order, or form a team, right? Represents as a class, there's no order. And then this is so much, this is how many teams you can get, okay, using the last formula. So there's basically three formulas here, right? One by one, right? Now let's do some problems, okay? So I'm going to only write down the problem numbers, okay? So I don't want to keep writing. Right. So the first problem says that a car holds exactly 5 people, but that only 3 out of 5 people can drive the car with a driver license. What is the number of ways that 5 people can be seated in the car on a drive? On a drive means the drive side must have the one was the drive side. Okay, drives, yeah. Okay. Must be seated a person with a driver license. Okay. So to do this assignments of seats, you have to do step 1, step 2, step 3, right? So each step there's an option, number of options. Okay. Let me show you do this problem, and then the rest of the problem you probably have to do by yourself. I will ask you to do this. So you label all the seats here. Okay. That's the drive side. Okay. That's a car. Okay. Car. There are 3 seats. I label them 1, 2, 3, 4, 5. Right? So different locations and different arrangement. Okay. All right. So how to do that? Well, 3 of them have driver license. So we'll have to make sure that for the first seat, right? For the first seat, I have 3 choices. Okay. Because I have to select the one with driver license. For the second seat, already one is gone, so I have 4 choices. For the third seat, 2 of them gone, 3 people left, so I have 3 choices. For the fourth seat, I have 2 choices. For the last seat, I only have 1 choice. Okay. Okay. So the answer is. The answer is 3 times 4 times 3 times 2 times 1. Okay, so this is going to be, you can multiply this out 4 factorial. Okay, so this will be the answer. Now you can compute it. Okay, I don't think it's 60, right? It's a 60 now. Okay, 4 factorial, right? 24 times 3. 72. Okay. 72. Clear? yeah, each seat, okay, has a number on that. You can also use a different name for the seat, like front side, drive side, passenger side, or whatever, right? But for each seat, you have to assign one person, right? When you permutate the two people in the seats, you get different arrangements, right? so that is a principal content, right? Then each step you figured out the number of ways to assign the seats, okay? Right? And you have to choose the driver side first. Otherwise, you cannot guarantee it. If you start from the back side, you cannot guarantee the last person will have driver license. Okay. 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 So take a look at the next problem. I want to do this first. Okay. I hope you learn this at principal content. Okay. You have to design the way. Okay. You have to design the way. The procedure. You have to design the procedure to complete this job, the assignments. Okay. This time it's not assignments. Just put the books to the shelf. Okay, I got one answer from a student. So how do we do that? Okay. I think step one, you have to decide, larger books first or the middle book second. You have to decide this order, right? So so 3 groups of books here, right? So the first step, I decide to which group of books you would at what place, right? You have 3 groups of books, right? And put them in order. So there will be 3 factorial, many choices. Then step 2, right? And this is for larger book. Okay, for the larger book, among the larger books, right, you can permutate 7 books. So that will be 7 factorial. And step 3, then you have to for media size book. Okay, it doesn't matter where they are, but you have 3 factorial remaining permutations. Then step 4, you complete the arrangements for the small books. Okay, that's 2 factorial. So the answer is, according to the principle of counting, should be 3 factorial first, 7 factorial, 3 factorial, 2 factorial. Okay, so if we multiply this out, and the answer will be, use the calculator maybe, 362880. Okay, good job. Okay, so you have to design the way how to do, how to make arrangements, right? So larger books must be stayed together. Medium-sized books should be also stayed together, put together. Okay. So similar problem over here. There are 5 Americans, 4 Chinese, 7 Spanish people sitting in a room. if people with the same nationality stay together, how many arrangements? Okay. Right? How many? So you have three groups, right? Group A, group B, S, right? So first of all, you have to assign the seats for the three groups. Okay, which group should be first, right? It's a similar, right? So it will be step one, right? Step one, and you have a 3 factorial, right? Many choices for those three groups. Then for American, you have 5 choices, right? 5 factorial permutations among 5 Americans. Among the Chinese, you have 4 factorial, many permutations, okay? Then for Spanish, it's 7 factorial. So you have to do all the computations then and you simplify. Okay, if you can use a calculator. So 720912000. Wow, this many permutations. Okay, so this many different arrangements. Yeah, why we have to study this type of problems? When you design telephone number, for example, right? How many digits should be in the telephone number? Then it depends on the population of the country. Okay, it depends on the population of the country. And if you have a less digit, if you know it's a less digit, sometimes at the end that's not enough telephone number you can use for the people, right? I think that's why in the United States we use such bigger number, you know, right? 3 digits plus 2 digits plus 4 digits total, right? Total, yeah, 9 digits. Okay. At the very beginning in China, the Chinese government thought there'd be not enough people use enough family use a telephone use a phone number. So the number is very short. Later on, they find out that so many people using telephones, and then have to change the phone structure of the phone number. Yeah. Okay. All right. So let's do the next problem. 4 boys, 4 girls will be sitting in a row. Okay. And there are 3 problems here. Find the numbers of ways in which 4 boys, 4 girls can be sitting in a row if the boys and girls have the alternate seats. Okay. So let's do the first one. Okay. Alternating seats. Okay. So you have to figure out the pattern, possible patterns. Okay. Right. There are 2 possible patterns. The first pattern, boy first. The second pattern, girl first. Yeah, 1, 2, 3. Okay. Right. So total you have 8 still. So for those, okay. Yeah. All right. So there are 2 patterns, right? Yeah. So for the first pattern, right? How do you do assignments? Just for the seats with the B, you put the boys there. But you have 4 boys, you can permutate it, so 4 factorial, right? That's the first step. Second step, to assign the seats for the girls, there are 4 seats for the girls, and then 4 girls that have 4 factorial. So this must be the product, okay? So this product is the total number of the arrangements for this pattern. And then similarly, you have this, okay? Add them together. The answer will be, after you multiply them out, the answer will be 1,152. Okay, let's do the second problem. Find the number of ways if they sit alternatively and if 1 boy and 1 girl are to sit in the adjacent seats. Well, Okay. So we only consider the following arrangement. Okay. So indicate the boy and the girl, okay, are sit in an adjacent. So there are 7 different positions for those 2 students. Okay, and once they are sitting, when their position is fixed, then you can do the rest of them. Okay, so we have seats, right? 1, 2, 3, 4, 5, 6, 7, 8. So you can choose these two seats. How many seats there, right? Step 1. Yeah, choose fix 2 seats for these 2 students. Okay. Select 2 seats, connect to each other. I'm sorry. Yeah. Select 2 adjacent seats. Okay. So you have 7 choices. 7, only 7. Okay. That's only 7. Right? Then step 2. Okay. Step 2, you assign these adjacent seats to the 2 students. Okay. Okay. So there are 2 seats there. So it's 2 factorial. 2 factorial, of course, just 2. Okay. All right. Now, here's the point. It depends on the assignment. If, okay, let's say if the third step, okay, you do the assignments for the rest of the students. So there's 2 possibilities here. One is boys on the left, right? Girls on the right. Okay, that doesn't matter, right? So here's a boy, okay, and girl, okay. It doesn't matter. If it's a boy on the left, you choose well, you only have 3 seats left. 3 seats for the boy, 3 seats for the girl. It doesn't matter which order they choose, okay? So there's a possibility, yeah, these 2 indicate students will be sitting in this order. The girls on the left, the boys on the right. It really doesn't matter. Okay, so, but you can always make alternate seats, okay? So it depends on the location they choose. Okay. Okay, so if so there are 3 seats. The other 3 seats must be in the alternate order. Okay, let's see. As this is 2 red. Okay. For example, I'm going to put G here. Okay. Right, and another boy or G here. Okay. Then this is the second pattern, right? G ball, GB, GB, and GB. I think. How many total? Yes. Okay. So so it doesn't matter in which order, right? In which edit. This is there's a 3 seats for the boys, 3 seats for girls. So this will be 3 factorial for the boys, 3 factorial for girls. Okay. So the answer will be the answer will be 7 times 2 factorial times 3 factorial times 3 factorial. Okay, that will be 504 different ways. Okay. The third one, find the number of ways if they sit alternately and if one boy, one girl must not sit in the adjacent seats. Then you just take the difference, okay? Because you don't need to do, you exclude the case that sit in the adjacent seats. So that is going to be 648. Okay. Yeah, this is the second problem is a little bit complicated, yeah, but that must be the in the alternate order, and you have to select a pair of the seats first, and then there's two options to assign the seats to the two students. But once they sit down, okay, then you look at the seats on the both sides. Okay, they must be in the alternate order. Okay, doesn't matter which pattern that there's a sit here. Okay, right? In which pattern? There's two patterns in the first problem. Okay, and then you just assign those three seats for the boy, 3 seats for the girl. Okay, this is the answer. Okay, this is a little bit difficult. Yeah. All right. So now let's take a look at the next problem. How many distinct permutations can be formed from all the letters computation? All right. Before we do this problem, maybe I should look at the simple case, just A, B, okay? You have 3 objects here, okay? You 3 objects here, right? So when you permutate those 3 letters, you're not going to get 3 factorial. You are going to get, first of all, you assume, those 2 letters are different, okay? So then you have, then you have A1, A2, and another one is A2, A1, okay? Then you permutate them, but you keep A1 first, A2 second. So this will be A1, right? B, A2, and the B, A1, A2. And here you get A2, B, A1, then here A2, BA2, A1. So total together, you get all the permutations, 3 factorial. However, after you remove this subindex 1, 2, okay, only the first row, okay, only the first row will give you 3 different permutations. Okay, the second row actually is identical as the first row after you remove 2, 1, 1, 2, the subindex. So that's why you divide by 2 factorial, you have 2 groups here. Okay, so the answer is only 3. Okay. Okay, you have a 2 factorial, two groups here. Okay, and each group, and those 2 groups, after you remove the subindex 1, 2, and then you get the same, distinct permutations. Okay. Now for computation, there are 11 letters there, right? But there are some of them identical for the same reason. Okay, how many O's there? There are 2 O's. How many T's there? There are 2 T's. How many I there? There are 2 I there. So you have to divide by this. Okay. So the answer will be after you compute it. Okay, 4989600. Okay. Okay. All right. So let's take a look at the next one. We're going to study counting numbers, okay? In how many 4-digit integers is 0 either the 10th digit or the unit digit, or both? Now this involves, yeah. So they are, be careful when you count them, okay? Be careful when you count them, okay? If you just, the best, yeah, if you look at the possible outcomes, will be like that, star, star, either the 10th digit, right? Or the unit digit, or both, okay? But this one is also contained in the first group, okay? So this group is A, that group is B, that group is actually the intersection of A and B, okay? Yeah, intersection of A and B. So you have a group A, group B, okay? They are the intersections that are common, okay? Because the last one, right? The units digit, 10 digit, both are 0, also belongs to group A, also group belongs to B. So when you count them, you have to be careful. Okay, that's A and the B. Okay, so this should be the unit, right? So the unit is A over B, the unit, okay? A up, cap, B. So we have a formula. If you count the number in the unit, and this first of all you have A, and the number in the B, and then the number in the intersection is double counted, so you have to subtract A and the B. Okay. So how many integers in the A? How many integers in the A? Right. How many integers in A? There's actually 900 integers in A. Why 900? Okay. So star, star, 0, star, right? For the first digit, yeah, you have 9 choices. Then you can choose any of them. 10 choices. And for the units, you have 10 choices. So you have 900. Okay. Similarly, if you have 900 integers in the B. Okay. Now for the last one, you only have 90 because for the last one, you only needed to select the 2 digits. So the first digit cannot be 0, so 9 choices. Second digit is 10, so it's 90. So the answer will be 1,710. Right. Okay. Another way to solve this problem is as follows. You can't, step 1, you count those 4-digit numbers without 0 without 10 digits or the unit digit not 0. No of them is 0. Okay. Okay. So in that, how to do that? Okay. So first of all, the number of all 4-digit integers, okay, is going to be 9 times 10 times 10 times 10, right? Okay. Right. Then I just needed to see the number of all 4-digit integers, and so that the units digit and the 10th digit is not going to be 0. Okay, it's not going to be 0, and the units digit is also not equal to 0. Then how to count them? First of all, you have 9 choices for the first digit. Then you have a 10th digit, right? Right? And For the 10th digit, the 100 digit is still 10. For the 10th digit, we have 9 choices, cannot be 0. The unit digit cannot be 0. So this is a total number, right? And then the answer will be the difference of these two. 9, 10, 10, 10 minus 9, 10, 9, 9. Right? And after you compute it, and they still get 1710. Okay. Just take the difference. Okay. You cannot count them directly. What you count them is that you count those integers. The 10 digit is not 0. The unit digit is not 0. And it will be much easier. Okay. Then you take the difference. Then you solve the problem. Okay. Either way. Okay. That gives you the same answer. Okay. All right, so let's take a look at the next problem. How many 4-digit positive integers whose product is digit of the digits is even? Okay, please work on this. Okay, anyone have answers? Okay, for this problem, you have to use the subtraction method again. Okay, otherwise, it's very difficult to do that. Okay. What are you talking about? Yeah. I'll give you a little bit more time to think about it. Don't talk about largest and smallest one. Okay. I just want you to find out how many. Okay. Okay. I think the first one is have to count those okay, the product is odd because it's easy to count those whose product is the product of digits is odd. The reason is the product of digits is odd if only if all the digits are odd. Okay. The product of digits is odd if and only if all digits are odd. Right. That's much easier. If the product of digits is even, then one of the digits is even. That's all you need. Then which one? How many digits are even? It's hard to control, right? You have too complicated. All right, so how to, yeah, so other digits will be 1, 3, 5, 7, 9. Okay, you have 5 digits. So you have a total how many choices, right? You have 5 factorial because you have 5 choices for the first digit, 5 choices for the second, 5 choices for the second, right? So if you multiply them out, it's going to be 625. So there are 625 integers who the product of digits is going to be odd. Then the answer is just take the difference. The total number of 4-digit integers will be 9 times 10 times 10 times 10, right? Minus 5 to the 5th, okay? So the answer will be 9,000, sorry, minus 625. It's going to be 8,375. Okay, so use a difference, okay? Wait a minute. Oh, the 4th power. Sorry, I have 4 digits instead of 5. Yeah, that's my mistake. So it's a 4 digits. Yeah, not 5 digits. 4-digit integers. Yeah. Okay. Yeah, use a. You count the integers. So whose product digits is odd will be much easier to do. Then you take the difference. Right? Then you take the difference. Then you solve the problem. Right. So take a look at the next problem. We have a several problem here. Consider all positive 3-digit integers with the 3 different digits. The 3 different digits. Okay. And note that 0 cannot be the first digit. Okay. How many are greater than 700? How many are greater than 700? The first question. And how many are odd? How many are even? How many are divisible by 5? Okay. Yeah, let's do the first problem. Okay. So you want to get digit. So the first digit must be either 7 or 8 or 9, right? So you have only have how many choices? 3 choices for the first digit, right? Right. See, since all the digits must be different, so if we select one of the 3 digits, how many digits are left, right? In the whole group, there'll be 9. Second step, the third step, there's only 8 digits left. It doesn't matter, it could be 0. So total will be, 216. Okay, 216. Okay. Yeah, this is you can also, well, you can use subtraction for this method. Okay, granted. Okay, but that's several ways to do. So let's do the second problem. How many are odd? To get odd number, right? So you have to have a 3 number, right? The last one, the last digit must be odd, right? Right, the last digit must be odd. Okay, can you figure it out? All the digits must be different. Yeah, if you have an answer, let me know. So 135. Now, yeah, you have this many digits you can choose, right? Okay. So in order to guarantee this is odd integer, so you have to select the units digit first. It's 5 choices. Yeah, this is for the units digit. Okay. Then, so one digit is gone. You cross one of the other digits. So for the remaining digits, right, you have to choose one for the hundredth digit. The hundredth cannot be 0, cannot be the odd, right? So there are only 8 choices. Okay. The one for the 10th digit, it doesn't matter. As long as not those 2 digits already select. So you only have you still have 8 digits left, right? You select one the 100th digit, you select one the units digit. Then for the 10th digit, you have 8 digits left. You can choose any of them. It could be 0, right? So this is the answer, okay? 60, right? Multiply them out, will be 320. 320, come on. Yeah, 320. Okay? Yeah. C. How many are even? How many are even? Now we have to be more careful about the even ones. Okay? I think if you do it directly, it'd be much more difficult. All I have to do is, when you get to the integer, right, either it's even or odd, right? Right? So if you can count those only the odd one, then it just take a difference. You can get the even one, right? So this is subtraction method, okay? So the number of 3-digit integers with distinct digits, right, is going to be, first of all, you look at the 100th digit, it cannot be 0, you have 9 choices. Then for the second one, you have 9 digits left, there's 9 choices. For the third one, you have 8 choices. So that is total. And then you already know the number of the other ones, right? So you just take the difference, okay? That's a 600 and 648. So the answer will be 648 minus 320, 324. Okay, but if you do it directly, and you have to be very careful about because there was yeah, it's a little bit more complicated. Okay, you needed to divide the even numbers into 2 groups, group A, group B, and group A contains the numbers ending in 0. Group B, you contains the number ending in a non-zero, okay, even number. Then you count the numbers in each group. That's just more complicated, so I'm not going to go through that, okay? So always use the subtraction method whenever possible, okay? So the last one, how many of them divisible by 5? How many of them divisible by 5? A number is divisible by 5. Here's my hint, right? It must be in the following form. Okay, either your end was 0 or ending was 5. Okay. Okay, so please work on this. I give you the hint. Yeah, you count them in the in each group, right? Group A, Group B, Group A, all those integers ending the unit digit 0. Group B is all those integers, the unit digit is 5, right? So what's the answer? Make sure all the digits are different, okay, Erica? All the digits are different. So it's not just a product, Yeah, your answer is wrong. Yeah, it's not 9 times 9 times 8 times 2. It should be the sum because all means usually sum. The first group, the number in the first group plus the number of the second group. Okay, we do not do the multiplication here. Okay. What happened, Taylor? You don't have answers right now? Oh, your answer was the same. Okay. Okay, let's do the first one. So you look at this, look at the number, look at the integer. The last digit is 0. So when you, so 0 is already select. 0 is already select. So for the remaining digits, there's no 0 there. So that's why for the first digit, you have 9 choices. Then 0 and the non-zero digit is used. So you only have 8 digits left, right? You have 8 digits left. It's a 3-digit number. Sorry, yes, 3-digit number. I have to erase one number. Yeah. So then you have 8 choices. Okay, so that's the total number in the first group. The total number in the second group, and be careful. Okay, 5 is already selected. 0 cannot be used. So only 8 digits you can choose for the first one. For the second one, 2 digits already used. So only 8 choices. Okay, add them together. The answer is 130. Yes, 130. Got it? Good. So it's clear, right? Now every time, yeah, you have to select it one digit for each place, right? So the first one, the second group, right? For the first one, 5 is already used, and the 0 cannot be used, and so 2 digits should be excluded first, and only 8 digits can choose. For the one in the middle, it doesn't matter. Just see how many. It's always 8. Okay, it's always 8. All right. So now let's do the problems here. So there are 6 bags numbered 1, 2, 2, 3, 3, 4. Using those tags, 6 tags. Okay, number. Okay, using those tags. So we have tag 1. Tag 2. Okay. how many distinct three-digit numbers can be formed such that two of the digits are the same? All right, this is a little bit complicated, right? Now, those are the object here, okay? It's not like abstract digits. So once you use it, you cannot repeatedly use it. Like you cannot have a 333 because there's only two threes there. Okay, two tags was the number 3. So you cannot have a 333. That's the key point. A typical example is 2, 1, 2. Okay, or 4, 3, 3. Example, I'll just show you. Okay, so that's my hint. Okay, please do this problem. Okay, so you got 12. I have more than that. My number is larger than 12. I think we're going to, first of all, figure out the 3 possible patterns. Okay, the 3 possible patterns that A, AB, A, BA, and the BAA. Okay, here A could be either 2 or 3. Clear, right? Either A or A equals 2 or 3, right? So 2, 2, 3, 3, for example. But once you choose A and right, or you can divide them into 2 groups, like a 2, 2B, 2B, 2, and B, 2, 2. Another group is 3, 3B, 3B, 3, and B, 3, 3. Okay. All you have to do is choose, select B in each group. The number of, right? And the B can be any number, can be 3, can be 4, can be 1, just cannot be 2. So for each group, 3B can be, 1, right? 3 and 4, okay? And here, B could be 1, 2, and 4, okay? So the answer will be, right? So the first one, the answer will be, how many, right? 3 times 3, right? 9, right? 3 times 3, it's 9, okay? Plus, you have a 3 times 3, it's 9. So it's 18. It is 18, okay? It is 18. Total is 18 because you have 3 choices for B, okay? Right? For each pattern, okay? You have 3 choices for B, okay? And so total, you see total here, you have you can say you have 6 groups here, 6 times, okay? Add them together, 3, 3, 3, 9, and 6 times 3. It's also 6 times 3 is also 18. So that's all, okay? And it have to be, you have to cluster them into several groups. Then you count them in each group. That's all you need to do. All right, great. That's all about today's class. It's about counting, okay? I think we're doing fine. Yeah, see you next class.